Okay, hello. So we're going to look at the last topic that we have on probability today, and that's a thing called permutations. And permutations is just another word for arrangements, and I'll give you an example to show what that means in a minute. Just before we begin, I want to remind us of the fundamental principle of counting. You already have this in your notes, but I'm just going to write it down again. The fundamental principle of counting, and we do need to know this definition, of course, tells us that when you have two events, the first with M outcomes, the second with N outcomes, then the total possible outcomes for the two events is M multiplied by N. And if we remember, some of the examples we had with that were if we rolled two dice, two six-sided dice, 6 by 6, 36 outcomes, which we saw in our two-way tables, 6 across the top, 6 down the side, and that multiplied together. So that's a fact that we're going to need to remember because we'll be using it when we learn how to calculate permutations, because these questions are all about how many different ways can you do something. So let's look at our first example. How many different ways can we arrange the letters A, B, and C? This might remind you a little bit of when we did sets and subsets. Now, the thing about subsets was that the order didn't matter. But with permutations, it's really important. The order does matter. That's what it's all about. It's about arranging things, the same number of things, but in different ways. So for example, ABC is a different permutation to BAC. Even though they have the same letters, they're arranged differently. So that's what we want to do when we're doing our permutations. Now, in these questions, they don't actually care what those permutations are. They're not going to ask you to write them out, usually. What they want to find out is how many of them. And we have a trick to this, but first let's do it the long way. Let's look at listing out the different permutations. So of course we could have the easiest one, ABC. And let's move the letter C all the way to the start, step by step. So we could have A, C, B, and then move the C all the way to the start, C, A, B. What about if we did this step but swap the B and the A around? So B, C, A. Or if we did this step and swap the B and the A around, so C, B, A. Now, are there any other ones that we haven't considered? Well, C has been in every possible position. A has been in every possible position. And B has been in every possible position. But if we notice, for this one and this one, we swapped around the A and the B, but we haven't done it for this one yet. So for this top one, leave C in the last position and swap the B and the A around. So there we go, we've listed them out. We're fairly confident that we've gotten all of them, but maybe we're not sure. Anyway, if we count them up, there's 1, 2, 3, 4, 5, 6. So the answer that we're actually looking for here is that there are 6 different ways or 6 different permutations of the letters A, B, and C. As you can imagine, if we have lots more letters, this is going to get more and more difficult. So what we'd like is a method that can help us figure out what this number is going to be without having to list them out. So without listing. How are we going to do this without listing? We use something that I call pigeonholes. The name isn't really important, but what it is we use a box. Use a box for each position. So let's look at what that's going to look like. We know we've got the letters A, B, and C. We know we've got 3 of them, which means we're going to have 3 pigeonholes, 3 boxes. So for example, I could put A in here, and B in here, and C in here. That gives me the first permutation. Or I could put B in here, C in here, A in here. That gives me the 4th permutation. And the way we think about it is, we look at the first box and we're trying to answer the question, how many choices, how many options do I have for this box? Well, the answer is, in this case, 3. I've 3 options because there are 3 letters. 3 letters to choose from. Now, once I've chosen that letter, and we don't know what letter it is, it could be A, it could be B, it could be C, but whatever letter I've chosen is gone out of my options. Suppose it was B. All that's left now are A and C. If I'd chosen A, B and C would be left. If I'd chosen C, A and B would be left. So for my second box, how many options do I have? Well, I've already used up one of the letters, so there are only 2 letters remaining. So that's the answer. There's only 2 remaining letters to choose from. And once I've used up 2 of the letters, there's only 1 remaining letter. Again, it doesn't matter what that letter is. I've used up 2 out of my 3 choices, and there's only 1 remaining letter for the last box. Okay, so here's where the fundamental principle of counting comes in. We said that if there were 3 ways of choosing the first one, 2 ways of choosing the second one, and 1 way of choosing the last one, the third one, then the total possible outcomes must be those 3 numbers multiplied together. So therefore, the number of permutations, or the number of ways of arrangements, is going to be 3 by 2 by 1, which is 6 different ways. So we get the same answer without having to list them out. That's my answer, 6 different ways. Okay, just a reminder that you can pause the video at any point sorry about the rattle. You can pause the video at any point to take down notes or rewind it or zoom in or anything like that. And do leave me a question if there's something you don't understand. Okay, we're going to do a second example now as it gets a little bit more difficult. This one's not too much different. So example 2. Let me just rearrange things slightly. This will get smoother with time, I promise. For my second example, the question is, how many different 6-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6. So an example answer to this, not the total number, we don't actually care what they are. But for example, the digit 2, 3, 5, 6, 1, 4. That's a 6-digit number that's formed out of those. But how many in total? Well, we're going to use our pigeonholes. And again, we have 6 possibilities and we're trying to make a 6-digit number. So we're going to have 6 boxes, 6 pigeonholes. 1, 2, 3, 4, 5, 6. And for the first box, I've got 6 different options here. So I've got 6 choices. Now I've used one up, so I have 5 choices. Now I've used 2 of them up, so what's remaining? 4 choices. I've used up 3, there's 3 remaining, used up 4, 2 remaining, and I've used up 5 out of the 6, so all that's left is 1. And you're possibly starting to see a pattern at this point. So the number of arrangements, the number of permutations, is going to be all of those multiplied together. And of course you can just use your calculator for that. So there are 720 possible combinations, possible numbers that we could form from those 6 digits. And it doesn't matter that they're sequential, it doesn't matter that they're consecutive. Okay, you might be noticing a pattern here. We have 6 by 5 by 4 by 3 by 2 by 1. In the previous one, we had 3 by 2 by 1. So there is a shortcut that we can sometimes use, and I want to talk about factorial notation. So some of you will already know this from junior cert, and I call them the most exciting numbers in the world. So for example, 3 factorial means 3 multiplied by every positive integer smaller than it. 6 factorial means 6 multiplied by every positive integer less than it. That works out to be 720. So hopefully you could guess what 5 factorial might be. Think about it for a second. It means 5 multiplied by every integer, positive integer, less than it. And I just happen to know that that is 140. Let me just double check that, sorry. That's 120, sorry, 120. Right, we are going to learn how to do factorial notation on the calculator, but we'll do that in a second video. I want to keep these around 15 minutes. I think that if we have 15-minute videos, they'll probably translate to 40-minute classes when you guys are sitting down to do the work yourselves. What you might do now, if you have a few minutes left, is try to calculate without, well, you can use your calculator, and I'll show you the shortcut in the next class. Try to calculate 4 factorial, 7 factorial, and this one's going to be quite big, 10 factorial. Okay, we'll stop there for now. Bye.